Hello class. So today we're just going to do something a little bit different. We're continuing with logic gates, but there's not going to be any new material presented, so to speak. I'm just going to basically give you your assignment that will be due on Monday. So as many of you know, my physics class is a little bit different than just about every other physics class in any high school. Just like the circuits we were doing right before we went on spring break, it's rare to find a high school physics class doing those types of circuits. They still do circuits, they just don't actually use real breadboards and real resistors like they do in universities. Normally they're the very simple kind where they just use bare wire and nails or something like that. Same thing with some of the topics we've covered in physics. We've covered a little bit, I would say a little bit higher order concepts, sort of like the electrodynamics, that stuff that you would see in a first year college level physics class. Actually, same thing with logic gates. It would be very rare to find a high school physics class doing logic gates. In fact, most of this is stuff you will come into contact with in your first 2 years in college if you're doing any type of computer science, computer programming, software, electrical, anything like related to that. So you have two things to do today. One is to watch a video. The link is posted on the assignments page, just where the link for this video was. It's a video from a university professor, a computer science university professor. He kind of goes through the same stuff we've been doing. He goes through the AND, the OR, and the NOT gates. So it'll be a really good review for you. However, he also shows a little bit different methods. I didn't show all the different methods. For one, I just didn't want everybody to get confused with which method to use, which way to do it. You saw some of the expressions I had. I did show you like two types of expressions for some of them, and I didn't want to show you more just because I don't want you to get confused. So moving forward, you just use the ones that I've covered, but it's really good to just see how the different things, and maybe you would see the way he does his truth tables. If you really like the way he does his truth tables, moving forward, you can start doing that way. Doesn't matter to me. I'm able to read all of them, so it's just whichever one makes more sense to you. Okay, but it's a pretty interesting video. And then, so your assignment, starting today, I want you to make a list and start today and do it throughout the weekend of any examples that you see or use or come in contact with that uses logic gates. And just give a brief explanation of why that is a logic gate. Don't just say cell phone, give me an actual specific example. And this could be anything. Trust me, you come in contact with a lot of logic gates throughout your daily life. You just have to think about them. For example, I'll give you one. If you use a timer on a microwave, or if you're just using the microwave, you still input the time, but if you want to use a timer on a lot of microwaves, somewhat different, you hit timer, then you input the time, and then you hit start. Well, what happens if you don't hit timer first? If you just input the time and then hit start, the microwave starts. Right? It's very simple, but that is a logic gate. And tell me what type of logic gate is. So it would be an AND gate. If I hit timer and a number value, and then I hit start, the timer comes on. But if I do not hit the timer, and I just hit a number, and then hit start, then just the microwave will come on. So that's a very simple logic gate. And it's actually a combinational logic gate. It's an AND and then a NOT gate for the microwave to come on if I don't hit timer. Okay, so you don't have to give a lot. I would say a minimum of 5. But if you're going to do the minimum, make sure you explain it very well. I want to make sure you really understand the logic gates, okay? Let's do